Hi everyone and welcome to lesson 15. In this lesson we're going to go further with the quadratic formula and implementing reducing the radical to simplest form like you learned in the last lesson. So for the do now, we're just going to do a quick review of the quadratic formula. I want us to solve for the zeros of this quadratic function using the quadratic formula, which I have right here. Okay, so the first thing we want to do is we want to identify our a, b, and c values. So our a value is that invisible number in front of x squared, which is 1. B is -5, and c is -14. Okay, now we're just going to correctly substitute following our quadratic equation guide here. Okay, so first we substitute the b right here, which is -5. Then inside the radical sign, we put b squared, so that's -5 squared minus 4 times a, which is 1, and then c, which is -14, divided by 2 times a, which is 1. Okay, so let's continue further. So we have x equals to negative times -5 is +5, plus and minus the square root. So -5 to the second power, if you put that in your calculator, make sure you put it in parentheses. It becomes +25. And -4 times 1 times -14. You could just do that all in your calculator. Oops, 4 times 14. And you get +56. And this is all being divided by 2 times 1, which is 2. So let's simplify this further. So we have x equals 5 plus or minus 25 plus 56 is 81 divided by 2. Now at this point, we can actually simplify square root of 81. If you put that in your calculator, or you know from the top of your head, the square root of 81 is 9. So this is going to become x equals 5 plus and minus 9 over 2. So at this point, we can actually solve for the actual values, not using radical form, but we can solve for the actual values here because we reduced this. We were able to reduce the radicals. So first, we're going to split this up into 2 equations. So one's going to be x equals 5 plus 9 over 2, and the other one's going to be x equals 5 minus 9 over 2. We're utilizing that plus and minus here. So 5 plus 9 divided by 2 is 7, because that becomes 14 over 2. 5 minus 9 over 2 is -4 over 2, which is -2. So our two solutions here are x equals 7 and x equals to -2. Okay, so now we're going to review what you learned last class, which was how do we reduce radicals that are not perfect squares. So you should have watched a video, and in the video, he shows you how to utilize perfect square numbers in order to break down the number underneath the radical sign. So first, what I want to do here is we're just going to write the list of perfect squares. So I'm going to write that down here for you. So perfect squares are 1, 2, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. So here, there's obviously many more, but I'm just writing the ones that we're going to be using for today. Okay, so we know how to reduce the easy ones, right? The square root of 36 is 6. Square root of 25 is 5, and the square root of 49 is 9. But how do we reduce something like the square root of 12, which is not a perfect square, but it can be reduced further? So the first thing you want to think about is, what is the largest perfect square number that is a factor of 12? So if I look here, 1 goes into every number, but it's not the largest, but 4 is the largest number here that goes evenly into 12. So I'm going to break this up as a product here. So I know that 4 times 3 gives us 12. So I'm going to break this up as square root of 4 times the square root of 3, because 4 times 3 gives you 12. And we also know the square root of 4 can be broken down further. Square root of 4 is 2. And we can't simplify square root of 3, so this simply becomes 2 square root of 3. Next, we have the square root of 18. So what is the largest perfect square number that goes into 18? So 4 doesn't go into it, and 9 goes into 18, and 16 does not go evenly. So 9 is the largest perfect square number that goes into 18. So I know 9 times 2 is 18. So I'm going to break this up as square root of 9 times the square root of 2. I know the square root of 9 is 3. And the square root of 2 cannot be broken down further. So we're just going to leave this as 3 square root of 2. Now, let's look at the square root of 33. This is a special case. If you look at all the numbers, 1 goes into 33, but that's not helping us. 4 doesn't, 9 doesn't, 16 doesn't, 25, 36 is too large. So as you can see, there are no perfect square numbers that go evenly into 33. Therefore, this cannot be reduced further. Okay? So this is a case where you would just leave it as a square root of 33, and you can't reduce any further. So let's take a look at 2 cases where we would have to reduce the radical sign while using the quadratic formula. Okay, so here I have the quadratic formula at the top. So if you want to write this down somewhere so you can use it, because you may not see it the whole entire time here that I'm writing on the notes. Okay, so first let's do what we do first, which is identify A, B, and C. So first we want to solve for our zeros using this quadratic formula. So first thing, our A value is 1, our B is -6, and our C is -19. So let's substitute A, B, and C correctly into the formula. So we have x equals negative B, which is -6. Be careful here when you have the 2 negatives. You need to include both. Plus and minus the square root of B squared, so that's -6 squared, minus 4 times A, which is 1, times C, which is -19, over 2 times A, which is 1. Okay, so all I did was substitute A, B, and C. Next, let's simplify further. So we have x equals, I'm trying to get used to writing on this tablet, it doesn't work. Okay, so we have x equals to negative times -6 is +6, plus and minus the square root. So -6 squared, remember if you're using your calculator, make sure to put -6 in parentheses. That becomes +36. And I'm just going to multiply this all together. So we have -4 times 1 times -19, which is +76. And this is being divided by 2 times 1, which is 2. Okay, so let's move on. we have x equals 6 plus and minus a square root. So 36 plus 76 is 112 over 2. So this is the part where we can reduce this square root of 112. So what I'm going to do is I'm just going to make a little kind of side note here. So here's where we're going to reduce the 112, okay? So I'm just going to list out the perfect square numbers again, like I did on the other page. So we have 1, 4, 16, 25. You don't have to memorize them. 49. I'm just doing it in my head. 64, 81. Okay, so those are our perfect square numbers. We know we want to simplify the square root of 112. So we want to think about what is the largest perfect square number that goes evenly into 112. So what I would do if I were you, if you're not sure, is to take 112 and divide 112 by some of these numbers. So let's start with, and just see if they go in. 112 divided by 81 doesn't go in evenly. 112 divided by 64, you get 1.75, doesn't go in evenly. Let's try 49 divided by 49 is 2 point something. Nope. Let's try 16. 112 divided by 16. And what do you know? It goes evenly, 7 times. So that means, since 16 goes into 112 7 times, we can break this down further into the square root of 16 times the square root of 7. And we know the square root of 16 becomes 4 times the square root of 7. So this means we're going to replace square root of 112 with 4 square root of 7. Okay? So here I'm going to put 6 plus and minus, and instead of square root of 12, we're going to put 4 square root of 7 over 2. Now, what is the purpose of this? The purpose of this is to reduce this. So what we can do now is we can actually get rid of this denominator of 2, because 2 goes into 6 and it goes into 4. So we're just going to simply divide, and that's going to be the end. So 6 divided by 2 is 3, plus and minus, and then 4 divided by 2 is 2 square root of 7. And that would be your answer. Okay? So this is, let me just rewrite this again. So this is 2 square root of 7. Okay? And that is your answer. So this is the simplified form. This would be a perfect answer if it didn't ask you for the simplified form, okay? So let's do one more together. So let's identify A, B, and C first. A is 6, B is -2, and C is -3. Okay, so let's substitute it into our formula. So you have x equals -2, which is our B, plus or minus the square root of -2 squared minus 4 times A, which is 6, times C, which is -3, over 2 times A, which is 6. Okay, so let's reduce this. So we have negative times -2, which is +2, plus and minus the square root. So -2 squared is 4. And now we have -4 times 6 times -3. That becomes 72, plus 72 over 2 times 6 is 12. Okay, so we're going to continue reducing this further. I made a mistake in the first video, so I And redoing this, I just realized, okay, so we're going to add the 4 and 72 under the square root sign. So we get x equals to 4 plus or minus the square root of 4 plus 72 is 76. And that's all divided by 12. Okay, so again, just like in the previous example, we want to see if we can reduce square root of 76. We know that's not a perfect square, but we want to see what is the largest perfect square number that goes evenly into 76. So I'm going to write them out on the side again. We have 1, 4, 16, 25, 36, 49, 64, 81. Okay, so just to save us some time, the largest perfect square number that goes into 76 is 4. So we're going to break down the square root of 76 into the square root of 4, and 4 times 19 gives us 76, times the square root of 19. We know the square root of 4 is 2, so square root of 76 is equivalent to 2 times the square root of 19. So I'm going to write it out as x equals to 4. Let me just redo that. X equals to 4 plus or minus, instead of square root of 76, I'm going to put its equivalent form, its reduced form, as 2 times the square root of 19 over 12. So now at this point, 12 does not go into 4 and 2, but you can reduce this as a fraction, as a whole. So I'm going to split this up a little bit so we can see this a little better. So it's x equals to 4 over 12 plus and minus 2 square root of 19 over 12. So I'm just splitting it up into the two fractions so you can see this a little better. So we're going to reduce these fractions a little further. 4 over 12, if you divide the numerator and denominator by 4, that reduces to 1/3, right? Plus and minus. And here we can divide the top and bottom by 2. It goes evenly into both the top and bottom. So this divided by 2. So 2 divided by 2 is 1. So we're just left with the square root of 19 over 12 divided by 2 is 6. So we're left with x equals to 1/3 plus and minus the square root of 19 over 6. And that would be our answer.